Still hand upgrading legacy Java? That's not craftsmanship, that's unpaid penance. Manual modernization is a failure mode, slow, error-prone, and permanently behind. The truth? AI agents now handle the drudgery with receipts. Here's what you actually get. Time back, CVEs gone, and cloud bills that stop bleeding. We'll walk a narrative case study, stack, benchmarks, results, plus a full audit trail so governance can breathe. There's one metric that embarrassed finance and delighted security. Stay for that. Now, here's what happens when you let Copilot app modernization drive. Case setup, the legacy stack, and the modernization mandate. Baseline first, we're dealing with a Java 8 era Spring application, classic MVC plus a sprinkle of scheduled jobs, built with Maven, running on AWS. Conservative governance, noisy alerts, everyone swears the app is stable while PagerDuty begs to differ. The stack has drift, parent POMs forked years ago, dependency versions pinned like insect specimens, and a CI pipeline that only passes if you chant. Average user behavior? Ignore the red badges, silence the scanner, and pray the next sprint includes tech debt. Spoiler, it never does. Pain inventory. Version drift means modern libraries won't resolve without exclusions. Dependency hell. Transitive roulette, where one logging upgrade detonates your HTTP client. Unpatched CVEs sit there politely waiting for an exploit kit. Idle compute waste, autoscaling that never scales down, instances at 8% CPU while finance funds a space heater. Add brittle configs, environment variables baked into user data, stateful file writes on disk, and secrets living where secrets shouldn't live. Constraint? This is audio only. No performative heroics, no live tab switching to Stack Overflow. We rely on reproducible artifacts, reports, commit diffs, scanner outputs, because guesswork is not a strategy and worked on my laptop isn't evidence. Why Java 21? Virtual threads change concurrency from a scarce resource to a commodity. Thousands of lightweight threads with minimal overhead. Throughput goes up, tail latency comes down. Garbage collection improvements, G1 and ZGC refinements reduce pause times. The foreign function and memory API is stable, which matters if you're calling native code or wrestling with off-heap buffers. Net effect, measurable performance and maintainability gains. Most people think upgrading is cosmetic. Incorrect. You get cheaper concurrency and fewer stalls, directly visible in service-level graphs. Migration scope, AWS out, Azure in, align with enterprise standards, consolidate billing, and plug into the platform your identity, policy, and observability already inhabit. We'll target Azure App Service or Azure Spring apps depending on the workload profile. Simple app service is fine. Spring-heavy microservices with scaling nuance, consider Azure Spring apps. For data, the mandate is Azure SQL database. Yes, you can keep PostgreSQL on Azure, but the business wants consolidation, so we'll map the path and show the trade-offs. Governance stance. Every action lands in Git. Diffable, reversible, attributable. The agent generates a plan, opens issues, and proposes commits. You approve. It resolves builds, patches dependencies, applies code transformations, using known recipes, regenerates the SBOM, and reruns scanners. If something doesn't pass, it loops. No Alt-Tab pilgrimage. And when it can't proceed, it asks for input and documents why. See the difference? Work becomes auditable instead of anecdotal. Before you let an agent touch anything, you assess. Automated inventory across modules, dependencies, build plugins, and runtime configs. Risk-ranked findings with references to advisories and documentation. Cloud readiness flags for service bindings, environment variables, and stateful traps that break when containers come and go. Cost baselines, compute hours, idle percentages, and the egress patterns that finance pretends not to notice until month end. You might be thinking, well, we can triage that by hand. Fascinating. And you're still surprised the app crashes. The average user misses the long-tail issues. Deprecated APIs deep in the scheduler, a logging bridge, masking duplicate class conflicts, or that one library pin that blocks everything from moving. The agent doesn't miss them because it doesn't get bored. So the modernization mandate is simple and final. Upgrade to Java 21, eliminate CVEs, containerize, migrate to Azure via CI/CD with controlled rollouts, enforce policy via approvals and key vault, and cut cost without cutting reliability. All changes trace back to commits with rationale. No black box, no swaggering hero commits at 2 a.m. Assessment first because guesswork is not a strategy. Then we execute. Assessment. The AI exposes technical debt with receipts. Here's what actually happens when you press assess. The agent doesn't scan. It inventories. Code, build files, plugins, transitive dependencies, Docker bits, environment variables, startup scripts, even those stray shell wrappers someone copy-pasted in 2017. It builds a dependency graph, annotates it with CVE data, and ranks risk. Not vibes, severity, exploitability, reachability. It's the Windows registry of your app's reality. Not just a list, your structural spine exposed. The truth? Most people think they know their stack. They don't. The agent finds the forked parent POM with a logging version pin that blocks every downstream patch. It flags duplicated SLF4J bridges that shadow each other like feuding roommates. It catches the servlet container that's quietly 3 releases behind because your CI only tests the happy path. And yes, it maps deprecated APIs you've been calling for years because nobody wanted to touch the job scheduler. Spoiler alert, you're touching it now. CVEs next, severity breakdown, affected libraries, and references to advisories. Direct links, not rumors. Critical and high get top billing, but it also identifies whether the vulnerable code paths are reachable by your application. Reachability matters. If a transitive library has an issue but your code never calls the vulnerable class, it's still flagged, but the agent prioritizes fixes that reduce real risk first. You get the remediation options, bump versions, add exclusions, or swap artifacts entirely. That's a menu, not a mystery. Upgrade readiness comes with receipts. Java 21 requires you to stop pretending it's 2009. The agent runs OpenRewrite recipes against your codebase in dry run mode, showing exactly which APIs are deprecated, which imports must change, and where behavior shifts lurk. It calls out illegal reflective access, JUC quirks, and the tiny landmines waiting in XML configuration. It notes frameworks that are ready, Spring versions, plugin compatibility, and those that need coercion. No hand-waving. Every proposed change links back to docs and migration notes. Cloud readiness is where your infrastructure signs go to be cataloged. The agent identifies stateful traps, writing temp files to local disk during requests, caching sessions in memory across instances, storing secrets in a text file under opt because someone needed it to work. It flags environment variable usage that assumes EC2 metadata patterns. It points out service bindings for Redis queues and databases that won't survive container churn. Then it proposes bindings the Azure way. Connection strings move to configuration, key vault for secrets, managed identities for auth. Like adults. Now the finance shocker, cost baselines. The agent pulls compute hours, instance sizes, scale patterns, and idle percentages from telemetry and infra definitions. It estimates egress costs based on outbound patterns. Yes, that one noisy batch job that hurls data across regions every night gets a line item. It translates all of this into a monthly number that doesn't care about your anecdotes. This is the number that embarrassed finance and delighted security. Why? Because eliminating CVEs while cutting spend is the only religion both teams share. Artifacts or it didn't happen. The agent produces a plan file with sections. CVE remediation steps, Java upgrade recipes, build changes, code transformations, containerization moves, and cloud target mappings. It opens issues per workstream, tags owners if you want, and scaffolds commits in a separate branch. Clean small diffs with rationales in the messages. SBOM generated, signed, and versioned. Vulnerability scanner outputs attached, that's audit ready from step 0. You want traceability? Every finding links to an advisory or a source document, NVD entries, project release notes, OpenRewrite recipe documentation, Azure migration guides. When it suggests replacing a library, it cites compatibility matrices. When it recommends moving a secret, it points to platform guidance on Key Vault and managed identities. It's not just because AI said so, it's because this standard right here says so. Controls remain human. The plan sits in Git, awaiting approval. You can adjust priorities, reject a remediation strategy, or demand a different target service, Azure App Service versus Azure Spring Apps, with the trade-offs listed plainly. The agent adapts, reruns the assessment delta, and updates artifacts. No sulking. Once you see the receipts, the posture changes. You stop debating if modernization is worth it and start sequencing the work. And yes, the average user will still try to ship a feature first. Fascinating. Meanwhile, the agent has already mapped the shortest path to a secure, compliant, cheaper runtime. Approve the plan, then watch it do the work you keep postponing. Automated upgrade from Java 8 to Java 21 without the drama. Plan approved, so the agent stops talking and starts doing. The loop is simple and merciless. Apply recipe, build, test, patch. Repeat until green. No heroic tab explosion, no forum archaeology, no try clean install. It uses OpenRewrite recipes to rewrite APIs, Maven enforcers to normalize versions, and a unit integration test suite to prove it didn't break your world. When a build fails, it doesn't panic. It bisects the failure, proposes a targeted change, and reruns. Discipline at machine speed. Dependency upgrades are where humans usually create chaos. Enter BOM alignment. The agent adopts the official bill of materials for Spring and related ecosystems, centralizes versions, and kills the version sprinkling across child POMs. It tightens version ranges to exacts or managed constraints to prevent transitive roulette, removes redundant exclusions, and adds the one exclusion that actually matters when 2 logging backends duel. Result, fewer surprises, fewer conflicting jars, fewer midnight pagers, stability. Now the code. Java 21 means your old APIs need adult supervision. The agent replaces deprecated classes and methods with supported equivalents, updates, imports, and adjusts method signatures where the platform evolved. It surfaces optional refactors, record and pattern usage, sequenced collections behind a feature flag so the diff stays minimal. It also addresses illegal reflective access by swapping in supported SPI or JDK sanctioned alternatives, then annotates the commit with a short rationale and links to migration notes. It's not just a patch, it's evidence. Security remediation is not an afterthought bolted to the end, it's inline. As dependencies move, the agent checks CVEs again, closes the loop on any residual findings, and regenerates the SBOM so your scanners see the new world, not your memory of it. And yes, it runs the vulnerability scanner and fails the build if something regresses. You called it strict. Correct. Security calls it minimum viable professionalism. Let's talk tests, because the average user loves to say, it compiles, like that's an achievement. The agent runs your unit tests, your integration tests, and if you've set them up, contract tests against stub services. When tests are brittle, it files issues with precise failure output and recommended fixes. If a flaky test is blocking progress, it proposes quarantining it with a tag, documents the risk, and keeps moving on non-risky areas. Momentum without denial. Benchmarks next. After the upgrade stabilizes, the agent runs targeted throughput and latency tests against the same workloads as baseline. The impact is where Java 21 earns its keep. More concurrent requests on the same CPU budget due to virtual threads, lower tail latency thanks to GC improvements, and fewer context switch penalties. You don't need to worship benchmarks to understand graphs that slope in the correct direction. The report calls out which improvements came from virtual threads versus GC tweaks. So you can credit the right feature when finance asks why the machines are suddenly less bored. Build hygiene matters. The agent normalizes Maven wrappers, pins the toolchain to a Java 21 distribution you actually control, and removes antique plugins that exist solely to make builds slow. It standardizes compiler flags, enables warnings as errors for the modules you approve, and adds static analysis where the signal is high. The goal isn't perfect. The goal is repeatable and dull, which is the gold standard for builds. Here's where the reclaimed hours show up. Historically, this kind of upgrade consumes weeks of senior engineer time, hunting transitive conflicts, unpicking arcane plugin failures, and babysitting flaky tests. The agent compresses that into days, not by magic, by not getting tired, not getting distracted, and not inventing side quests. Your humans spend their time reviewing diffs and making judgment calls, not guessing version numbers. And when the loop converges, recipes applied, builds green, tests passing, scanners quiet, you have a clean branch with small, well-labeled commits. Each message names the change, the rationale, and the source. Rollbacks are obvious, approvals are fast, auditors can read them without calling you. Also, your pager is silent, which is how you know modernization happened instead of cosplay. Modern runtime secured. The app is faster, safer, and frankly more adult. Now the cloud bill and topology need surgery. Cloud migration, AWS out, Azure in, with pipelines and policy. Everything changes when the runtime is sane. Now we move the furniture. Target architecture first, because random lifting creates random outages. For a single Spring MVC app that isn't pretending to be a service mesh, Azure App Service is the efficient path. Simple deploys, built-in scaling, and no surprise Kubernetes cosplay. If you've got multiple Spring microservices, service discovery, and config churn, Azure Spring Apps earns its keep with managed Spring bits and blue-green out of the box. The agent doesn't guess, it scores the workload on features, statefulness, and traffic, then recommends with trade-offs and cost notes. You approve. It proceeds. Data is next, and this is where adults separate from hobbyists. The mandate is Azure SQL Database. Yes, I heard your PostgreSQL nostalgia. Governance wants consolidation, identity wants managed auth, and finance wants one bill. The agent inventories JDBC usage, connection pools, and driver assumptions. It swaps the driver, updates the JDBC URL, adds retry logic suited for transient errors, and services ANSI SQL deltas where you wrote dialect-specific queries. If migration friction is high, it proposes an interim landing zone on Azure Database for PostgreSQL with a future cutover plan, clearly labeled, timelines included, options with receipts. Containerization isn't a personality trait, it's a repeatability tool. The agent generates a Docker file that actually builds multi-stage, minimal base image, non-root user health checks. It bakes in JVM flags aligned to Java 21 and your memory budget, not a random copy from a blog. Then it emits infrastructure as code, bicep or ARM templates to provision app service or Azure Spring apps, app service plans, key vault, identities, and networking. One environment definition per stage, dev, test, prod. Same shape, different sizes. Fewer surprise failures because the machines stop improvising. CI/CD is where the will deploy later myth goes to die. Enter GitHub Actions. The agent scaffolds workflows that build with the pinned Java 21 toolchain, run tests and scanners, build and scan container images, and deploy through environments that require approvals. Rollbacks are a button, not a seance. Previous image tags, previous slot, previous template. It wires smoke tests post-deploy and gates promotion on success. You don't hope prod looks like test, the pipeline enforces it. Secrets are not environment variables in plain text, they live in key vault. The agent provisions vaults, creates references, and switches the app to managed identity. That means no embedded keys, no accidental config commits, and no late-night rotations because someone leaked credentials in a screenshot. It also adds conditional approvals. Security reviews happen when the SBOM changes, cost reviews trigger when plan sizes increase, and break glass is logged when you override. Guardrails without friction. Adults keep receipts. Cost reduction isn't a prayer, it's architecture plus policy. The agent right-sizes plans based on measured CPU and memory, not ego. For non-production, it recommends scale to zero or consumption-style options where supported. For production, it sets auto-scaling rules on real signals, requests per second, CPU, queue depth, and caps maximum instance counts with a documented exception process. Egress gets trimmed by co-locating services and switching chatty nightly jobs to intra-region paths. The before and after estimate lands in the repo. Instance hours, storage tiers, data transfer. Finance recognizes numbers, give them numbers. Network and reliability aren't afterthoughts either. The templates add health probes, readiness checks, and connection draining so your users stop noticing deploys. If compliance demands private endpoints, it sets them up, pushes traffic through application gateway or front door, and configures WAF policies you can actually read. Logging routes to Azure Monitor with structured fields. Dashboards pre-baked, latency, error rate, saturation. Boring visibility is the goal. Cutover follows a script, not vibes. The agent stages the environment, deploys to a new slot or instance, warms it with synthetic traffic, and runs contract checks. Then a controlled switch, DNS TTLs adjusted if needed, slot swap if app service, traffic splitting if Spring apps. Rollback plan remains armed until user traffic proves the point. The report calls out impact windows, who approved what, and where the escape hatch lives. This is how you avoid 2 a.m. folklore. Policy integration ties the room together. Approvals for security-sensitive changes, cost checks for plan upgrades, and compliance attestations baked into the workflow. Every action lands in Git with rationale. Auditors see intent, change, and verification. No black box, just a disciplined choreography where the agent does the heavy lifting and you retain the steering wheel. Result: AWS out, Azure in, pipelines humming, policy enforced, and the cloud bill finally acting like it's on your side. You're welcome. Results and benchmarks. Time, CVEs, cost, and hours. Let's talk outcomes, not vibes. Timeline first. The upgrade and migrate sequence that historically swallows a quarter went from months to days. Assessment and plan in hours, Java 21 upgrade in a couple of working days, cloud migration prep, and pipelines inside the same sprint. Calendar effect. Features stop queuing behind upgrade season because there is no season, just disciplined automation running continuously. Security next. CVEs don't care about your roadmap. The agent moved critical and high findings from present and exploitable to resolved, regenerated the SBOM, and produced scanner reports that matched reality. Residual medium and low items were documented with reachability notes and remediation timelines. The important bit, risk trend turns down and stays down because the pipeline rescans on every change. Cost reduction shows up where finance actually looks. Compute hours right-sized to real load, non-prod environments set to scale to zero where supported, and egress trimmed by co-locating chatty services. Before, instances idling at single-digit CPU, transfer charges spiking on nightly jobs, storage hoarding data you'll never read. After, instance counts align to demand curves, batch jobs stay intra-region, storage tiers match access patterns. The number that embarrassed finance and delighted security? Total monthly run cost dropped while CVE count dropped. Fewer dollars, fewer vulnerabilities. Both graphs move down together. That never happens by accident. Developer hours reclaimed aren't theoretical. Senior engineers stop babysitting dependency roulette and brittle builds. The agent's loop, apply, build, test, patch, replaces the least creative part of their job. Those hours shift to performance work that compounds, optimizing hot endpoints, deleting dead features, improving observability. Portfolio-wide, the pattern scales. Once your playbook exists in Git, other apps adopt it, and the upgrade tax stops accruing. Reliability signal improves because the pipeline enforces adulthood. Build success rates climb, test pass rates stabilize after flake quarantine, and rollback drills become a button instead of a ritual. Deploy frequency increases without error rate penalties because the shape of dev, test, and prod stops drifting. Confidence becomes a metric, not a speech. Transparency ties it together. Every change is a small, reviewable commit with rationale and references. Reports live beside code. Auditors answer their questions without summoning engineers. Leadership sees cost, risk, and velocity in the same pane. And the pager? It's still quiet. Numbers matter, so you get them with receipts. Governance, audit trail, and model transparency, no black boxes. Traceability is the baseline, not an extra. Every action lands in Git with a reason and a link to an advisory, a recipe, a migration note. You don't approve AI magic, you approve specific documented changes. Rollback is a Git revert, not a war room. Explainability isn't optional. The agent attaches why notes to each fix, Which CVE, which API deprecation, which Azure guideline, model outputs map to standards you already recognize. If a suggestion deviates, it flags the variance and waits for a human. Control stays where it belongs. Controls are layered, not performative. Human in the loop, checkpoints at plan approval, security-sensitive changes, and environment promotion. Conditional gates trigger when SBOM deltas are large, when plan sizes increase cost, or when network posture changes. Break glass exists, is logged, and is audited after the fact. Adults sign, systems remember. Reporting is visible and dull, exactly right. Power BI dashboards pull from Git, scanners, and pipeline runs, time saved, CVE trend, cost curve, deployment health. You can filter by repo, team, or environment. That means governance reviews look at facts, not folklore. Compliance posture is repeatable because evidence packs assemble themselves. Commit history, SBOMs, scanner outputs, pipeline logs, and change approvals bundle into audit artifacts aligned to your frameworks. You run the play again next quarter, and the output matches because the process matches. So, should you still fix legacy Java by hand? No, obviously. Here's the takeaway. Manual modernization is waste. Agent-driven audited automation is the new baseline for speed, security, and cost control. If this saved you time, do the efficient thing, subscribe. Next, I'll wire the Power BI dashboard and pipeline triggers end-to-end so your reports update themselves and your deploys behave. Enable notifications and stop learning by outage.